Hello, everyone. Today it's another stream. We're talking about implementing a backend for your Webflow applications, and we're picking up from the previous stream where we went straight into Webflow. We did not talk about backend, and we talked about how to implement an Auth0 application in Webflow. So strictly talking about the front end itself. So we implemented these login and logout buttons. We were able to successfully log in a user send the user to the SSO page that Auth0 implements for us, send the user back to our page, get an access token, and also allow the user to log out. So all of that was implemented in the previous stream. And now we're able to retrieve these access tokens. So the next step is to use those access tokens for our backend that we created in other previous streams. Okay? If you need some extra context, in the previous streams, we built a small backend for creating and updating to-dos, basic to-dos list for users. So now with these new access tokens that we can retrieve from Auth0, we're going to use them to identify our users in our backend APIs.
That's sweet.
Today, I'm going to go a little bit more technical because I want to go in depth about how access tokens, in particular JWT tokens, work. How does Auth0 generate those tokens? How can we decode and validate those tokens? What's the info that those tokens carry? And how can we use those tokens to successfully identify a user in our backend? So let me go to the front end code base, which is this one, and I'll run pm dev because we already had the code for loading and creating an Auth0 client on the page and then allowing the user to log in. So let's do it again. And if I remember correctly, we are console logging the access token after we successfully log in. So I want to talk about that access. So let me open everything. Let me open the console. Let's do some zoom in here. And let me see. Okay, so first of all, we're not logged in. That's good. Okay, so let's click on login. We're going to go to the SSO page. And now I realize that we have a problem, and it's that I completely forgot the password of the user that we created. So let's now learn how to change the user's password in Auth0. So in Auth0, we can go to the dashboard. There's user management, users. And essentially here you have a full-blown dashboard to manage all the users from your application. So let's go here and we can manually change the password. So let's just do it. For example, I'm going to use this one suggested by password. Cool. So I think that password was changed correctly. So let's try to log in. So this was test@test.com and password. Let's see if it works. Cool. Okay. So we're logged in. We have correctly exchanged the Auth0 token, and we got the user information and the access token. Okay. Copy this. Copy string contents. And let's jump back again to the JWT page. We have the JWT, the access token. We pasted it in here. And this website decodes the token for us and shows us the header, the payload, and the signature. Okay, well, it doesn't show the signature, but we can use it to see if it's valid. Okay, so let's first understand what's the JWT and how does it work? How do we handle the data in it and make sure that nobody else can mutate it, nobody else can hack us, right? So this access token, you can see how this is already being represented in 3 different colors, like this. So we have the header, we have the payload, and we have the signature. Okay, the header just contains information about the token itself, like how was it generated, with what algorithm was it signed, was encrypted, and an identifier that belongs. Yeah, we'll see about this identifier. the payload contains information of the user itself or the application that we're dealing with. Okay. For example, we can know who issued the token, and in this case, it was Auth0. We can see the user ID, and usually it's represented with the sub key. Okay. We can see the audience, and this is important because in Auth0, I touched this briefly in the previous stream, but in Auth0, you can have multiple audiences. You could have multiple applications, but maybe that you have also different backends with different access, with different rules. So you can have that in the API section. So essentially, you can have multiple audiences. So that's reflected also in the token. It also has when the token was created. It also shows when the token expires, because the tokens have a specific lifetime. You can also see the client ID. This was, I remember you, Penny, noticed this. And also you can see the scope of the token. Maybe there are some permissions that are included. Maybe there are some permissions that are not included in the token, and you can check that. Okay. So that's good. Now, my question is, what about the signature? What the hell is about it? Let's see. Let's try to understand what's going on here. So the way that the signature is generated for an access token, it's we take the header and the payload. We take both. We just put them together, and we encrypt them using a private key that it's only accessible by the emitter, by the person who's generating, not the person, but the entity who's generating the token. Okay, so that private key, it's used to encrypt the contents of the payload and the header. Okay, if the payloads of the content or the header change, then the signature is going to be different, meaning that this signature is only valid for this specific payload and this specific header. When this changes, only the entity who has access to the secret key, the key that it's used to encrypt the data, can properly make those changes and emit a new access token that it's valid. Okay, and this is very important because the access token, as I'm showing to you right now, it's public. Okay, it's public in the sense that you can get it. I can get it, me as a user. So you would think, okay, what if I just take this and instead of me being this user, I'm going to decide that now I'm a different user. And instead of being 35, I'm 36, whatever. Okay. The problem is that I can try to, I could generate the header for it. I could generate the payload, but I am not able to generate a valid signature because I don't have the private key. The private key, it's only accessible by Auth0 and by people who own the Auth0 account. So I'm not able to modify this access token unless I have the private key, which is very important. Okay. So now let me go back. Whoops, not go back on the site. The private key is on the server, correct? In the case of Auth0, it's on Auth0's server. And actually, I'm going to show you now where can you find it. But you don't actually need the private key ever in Auth0, okay? Because I also want to mention how does Auth0 generate these keys and how does Auth0 use those keys. So let me actually retrieve again the token. Okay, like that. Okay, so there are actually two ways, but there are probably more ways, but I'm going to talk about two different ways where access tokens can be encoded and decoded. Okay, the first way, and it's the easiest way, the most traditional way, it's called symmetric encryption. So we'll have symmetric encryption and asymmetric encryption. Okay, and we actually can use both in Auth0. Okay, by default, Auth0 provides asymmetric encryption, and it's the one that it recommends, but we can use both if we wanted to. Symmetric encryption, it means that there's just one secret key. So there's one secret key, and this secret key, it's used both for generating the access tokens, so for encoding or encrypting the access tokens, and also it's used for let me actually say encoding the access tokens. And also it's used for decoding and validating the access token. So it's the same key, meaning that if you lose that key, obviously you're fucked up because they can access essentially everything from your side. So please never expose these kind of keys anywhere publicly. This it's good because if you have a backend, you have the secret key and you take care of encoding, decoding, everything is fine. Okay, but there's a better way to do it, especially for services like Auth0, when it's another party who is taking care of creating the keys, and we just want to handle the part where we decode and validate the key. Okay, because this part in here, it's being handled by Auth0. Auth0 generates the access token, but then it's up to us to make sure that when we implement it in our backend, we get the access token and we make sure that the access token it's valid. Okay, so there's actually this other approach that it's called asymmetric encryption. And instead of having one key, there are two keys. There is one private key, and there is one public key. And essentially, the way that this works is each key has its own purpose. So there is one key that it's used for encoding, which would be the private key. And there's this one public key that it's used for decoding and validating. Okay, the private key, it's in Auth0. We can access it, but we really don't need to because Auth0 it's generating the access tokens for us. That's fine. We don't need to do anything else. And then the public key, it's literally public. Anybody can access it. And I'm going to show you where you can find it. And it's used to validate that an access token is valid. Okay, and let me show you. We're going to go here and we'll try to validate this access token. So right now it's saying signature verified, but this is because this app works weird. It's weird. But I want to show you how we can try to validate this. If we go to Auth0, we go to applications, we try to look for our application, and we'll go down here to advanced settings. And we can find a new tab that is called endpoints. Okay. And this endpoints tab, there is one specific endpoint that it's this one from here, JSON Web Key Set. Essentially, this is the page that Auth0 hosts for us, and it's exposing to the public keys used for validating an access token. So let me show you. So we're in here, and this is what we see. Okay, there are two keys. I'm going to tell you about why there are two keys, but just focus on one. Okay, and this key, it's what's used to validate a signature. Okay, this key can be accessed by anybody, which means that I can validate an access token, Henny can validate the same access token, Keegan can validate the same access token, anybody can validate the access token. But only the person who has the secret key can actually modify the access token and keep it valid, keep it trustful. Okay, so let's pick this, and I think that we will have to do an update because hold on a second. Oh no, it worked fine. Okay, so see how now our signature it's verified. If I change this, now we can see how this signature is invalid. But let me put it again. The token, signature valid. If I change something from the payload and instead of having the header like this, I decide to have the header with another key here. Now the signature is no longer valid because let's remember that the header and the payload are the base of the signature. If something changes, the signature is also different, and we don't have the private key to generate the new version of the signature, so we have no way of mutating this in a malicious way. Only people with the private key can do it. Cool. So now that we know how the workflow looks like, now let's go back to our backend and let's implement this. Okay. Let's Let's remember that we have a backend that we are building using honojs, which is the routing framework, and we're deploying this backend to Cloudflare workers. Okay, everything that I'm telling you about, it might not be the same exact code, but it's still a valid concept to follow if you're implementing the backend in any other framework or any other runtime. Let's remember that we have an endpoint called get-to-dos. Okay, and from this endpoint, what we want to do is retrieve the user ID from the headers, and then use that user ID to fetch the to-dos. Okay, so let's go to the Authenticate middleware that we created. There's one stream, I think it was 2 streams ago, that we talked about middleware in our backend API. And in that case, we created this very simple Authenticate user where we got the header, which is incorrect, by the way. I realized that I made a mistake after the stream and I wanted to correct it. Because the header, it's not called authentication, it's called authorization. So if anybody's watching this and thought that I was wrong, you actually were right. I was wrong. I'm sorry. The standard, it's calling the header authorization, not authentication. Okay, and that header contains the bearer token, which contains the access token. And in that case, we use that as a user ID. But now we have to implement an extra step. We have to implement and decode the token, validate the token, and extract the user ID from the token. Okay, this is our tasks today. We want to do these things: decode the token, validate the token, and extract the user ID from the token. Now, if we check any guide on the internet, you will always see that they suggest you to use a third-party library to do this. And the reason is because it's not simple to do these kind of things. You have to deal with cryptographic methods. You have to understand what's going on and if you're doing it correctly. And I'm no expert. I'm no expert in this. So I'm also going to use a third-party library for this, but I'll try to explain as much as I can the process that the library is following. Okay. In our case, I'm going to suggest to use a package called Jose. Sounds very Spanish, but there's actually a reason. It's an acronym for JSON. Can't remember. JSON object signing and encryption. So it sounds like it's a Mexican name, but it's not. It's actually an acronym, okay, or a Spanish name. So this Jose provides all the methods that we need to use for decoding and validating the token and extracting the payload from it. Okay, so let's install that in our code base. I'll bring this up and I'll say pm add Jose. Oh yeah, I forgot. Don't mind what's happening here. It's unrelated to what you usually would encounter. Okay, 1 second. Let me do it again. Now it seems to work. Okay, great. So what we can do now is import this package, and we'll say import everything from Jose, like that. And hold on, because I have another. Oh yeah, like that. So we are importing everything from Jose, but now we'll use a few methods from it. The first method that we want to use is this one. We have to decode the token. And to decode the token, we have to actually wait a second, because maybe it does it automatically for us. Oh, it actually does it. So decode and validate the token. It's done simultaneously by the library. It's a very cool library. So what we're going to do is we need to get this URL. Remember the one with the public keys? This URL, we're going to give it to Jose. So Jose can automatically go and fetch these public keys and compare and use that to decode the token and validate the signature of the access token. So we're going to take this URL and we're going to define it here. And I'm going to say the URL, it's this URL. in here. I believe that you actually don't need it to be a URL, or maybe you do. So it could be just string. No, it has to be URL. I'm checking my notes. So what we're gonna do now is let's create a JSON web keys store with a method that Jose already provides, that it's jose.create remote JW key set. And we just need to pass the URL to it. What this method does is Jose is just going to go and grab the keys from the public page and store them in memory, so then it can use it to perform the actions. Usually, this makes sense specifically in a Node.js environment where you have a server that it's long-lived, because then this means that Jose doesn't have to go every single time to get these public keys, because otherwise, in every single request, Jose is going to have to visit this public page, get the keys, and then use them to validate the token. So this is why they provide this helper function. But let's remember that in our case, we're in serverless, which means that every single request that we get, it's a different instance that it's running. So it doesn't make sense to try to store this in memory, because the memory is destroyed after each request. Now, what we have to do is validate this. And for that, Jose, it's going to be a result. Jose provides a method called JWT verify. Wow. Yeah, it's pretty easy to understand that. I think that there are a couple more methods that get confused, but yeah, let's just go with JWT verify. Okay. In this case, user ID is no longer user ID. It's actually coming the JWT, or the access token, like this. And we want to verify this access token, so we will pass this. We'll also pass the JSON web key store that we passed. And lastly, we have to define what are we validating this for. Okay. Let's remember that in here, we have a specific audience and we have a specific issuer that it's from Auth0, right? We have to pass that to Jose so it can make the proper comparisons, because it could be that we are now validating this for one API. In this case, it's the stream API, and we define this audience. But maybe there's another API and we want that to be different. So we have to tell Jose that we're validating for this specific audience and for the issuer, which is Auth0. So let's do that. We'll come here and we'll say the audience, it's, I think it's this one. There are actually two audiences. So we're going to pass an array and pass both audiences. It's the audience from the one that we customly define, and also another audience that Auth0 injects when retrieving the user information. So we'll have these audiences. And lastly, we'll also have the issuer, which in this case, it's this. It's the cloudflare stream.us.auth0.com, which is our Auth0 domain. Like that. And just like that, now we're able to retrieve the result from it. Let's see what's in the result. We have a key, we have the payload, and we have some extra headers, which, essentially it's the three parts from the token. Okay, so let's do this and console log the result. Let's just do this. And for now, I think it's fine. We can leave it as is. Instead of doing this, let's create another endpoint. Let's say /get test, and we'll authenticate the user, and then we'll just return hey. Okay. We have now a very basic endpoint, so we can log stuff and check what it does. So let me run pnpm dev. I think it's okay. Cool. Yeah, it's fine. Test. Missing authentication header. That's good. Okay. So let's go back to the endpoint. Now we're expecting this endpoint to have an authorization header that contains the bearer token. So we have to send that, otherwise we're throwing an error saying, hey, this is missing the authentication header. Okay. So what we can do is let's go to our site. And let's remember that we are currently logged in. We have the access token here. Okay. So I can essentially call this endpoint. Let's try to do it manually so everyone can see exactly what's going on. I'm going to fetch this. I'm going to include the headers. And inside the headers, I'll include the authorization, which is going to be the bearer, space, and the access token. Like this. Okay? Let me wait for it. And I want to see the response, which in this case, it worked fine. This is good. And let's check the console. And this is the result that we got. We got, we got an object and nothing else. So let's try to be more specific about what we're consoling. Sorry, let's say console log the key and the payload and the header, like that. Let's do it again. Let me call this, and let's check again the console. So hopefully we can see some more info. Okay, that's good. We are almost there. The problem is that this console, it's not showing much. Let me see if I can do it better. Or you know what? Let's actually return the result. Let's say result. If you want to know what I'm doing here, remember that this is a feature from honojs that you can pass properties inside the context. So let's do this and let's get the result. And let's pass that as JSON so we can inspect a little bit better what's going on, like that. So let's call this one last time. And let's see what the response comes as. Okay. So see, this is what we're getting from the decoding of the token. We're getting the header that contains the information from the algorithm and the ID of the public key. We have information about the key that was used. And also we have the payload. And this is what we care about. We care about this thing because it includes the user ID. And this is exactly what we needed. We needed the user ID to make sure that we're dealing with a user who is logged in and it's authorized to call this backend API. Yeah. So we know that we can retrieve the user ID from the sub property. Here we have it. Let's go back here. We can get rid of this. Actually, let's get rid of this test endpoint. That's fine. And now, instead of setting the user ID as the access token, we can set it as result.sub. Result.payload.sub, like that. So now we know that it's there, that the user ID is there. But I want to do one extra thing, and I want to make sure that this user ID exists, because otherwise we have to throw an error. We have to make sure that the API endpoint is fully protected. So what I'm going to do is I'm going to check if the result payload has a sub-property. Because if it does not have a sub-property, I will throw an error saying that, I don't know, unable to identify the user, whatever. Identify the user. So now what we can do is try to call this endpoint with an invalidate access token, just to see if we're actually able to do this or if it's not working correctly. So I'll use again the /deduce, because in this case, it was already prepared for retrieving the user ID, and then calling calling the KB to retrieve all the stream to-dos that are tied to this user ID. Let's try it. Let's take this, but instead of being /test, it's going to be /to-dos. Obviously, now we're getting this because it's missing the header. But if we go back here and we use this /to-dos, this should work fine because we're passing a valid access token. We're probably not going to retrieve anything because there are no to-dos stored to the user. But if I try to do this with an invalid access token, let's just do something random like this. Look how this now is returning an error. So this is saying, hey, the signature was not valid. Something was missed there. And this was an error that was thrown by Jose itself. When trying to decode and validate the token, it identified that the token is not correct because it's not matching the public signature. So what it's missing now is creating new to-dos. We have to create new to-dos and then store them in the KB and retrieve them using the official Auth0 user ID that we have created and retrieved. Okay? So let's go back to this front-end code base. Let's remember what we have here. We just have an init function that creates the client and all that stuff. And we have the login and logout buttons. But let's handle again all the form stuff. Because I created that in a previous stream, but I never migrated it to the proper code base for the front end. So I'll just take this and move it here to the front end. And I'll create just another file. Let's say, I don't know, form, for example. Okay, I'll do this. And let's remember we have a get user ID, which in this case, it's not correct because we were using local storage. We no longer want to do that. So I'll get rid of this, rid of all of this. Yeah, I'll get rid of all of this. And instead of user ID, in this case, we will have an access token, which is going to be a string. Okay, this is our function. We call the /to-dos with an access token. And the form submission, I know that the form is there. Let's create a function for that. Let's say handle form submissions, whatever. And let's move all of this inside that function so we can call it later. But we'll put the form also inside here. We'll make sure that the form exists. It could happen that there's no form. Like that. We can add an event listener. That's good for submissions. We get the form data. We get the title. We get the completed. So essentially, we get the information from the form. Zoom in. That. And then we submit it to the backend. And in this case, the form submission happens right here. Let me actually do a response with a sync await. Let's do it correctly. We have the response. We're gonna get the data, and then we'll just console log the data. And we'll wrap everything in a try catch just to make sure that if something breaks, we can at least know that failed, and we'll console log the error like that. Okay, good. The only thing that it's missing is the actual user ID. Should be an access token. So also let's pass that as a prop like that. And here, okay? And I think that's it. Now we can start doing stuff. So let me export this. And I think that instead of calling this form, it makes more sense to call this to-dos because it loads the to-do. There's a function for loading the to-dos, and also there's a function for handle to-dos form. Maybe it's more descriptive like this. Yeah, let's keep it like that. Okay, so we can do this now. Let's handle the form. Let's send the access token to the backend. let's make sure that everything is working fine and that we can identify the user. Okay. So in the here in window.webflow, I'll do also handle to-dos form and load to-dos. I think it's fine if we do it down here. I know that this can be better organized, but it's just for the sake of the demonstration. This is expecting me to pass an access token. And let's remember that the access token was here. So what I'm going to do is, because we have a problem of structure here, because I want to make sure that we get the access token. And to do that, we have to make sure that we are logged in. So I'm going to say, if we're not logged in, return in this case, and we'll do this exact same thing down here, like that. We can make this a sync. Okay, and then we can pass the access token in here. Okay, so let me recap what just happened here. We're using the same code for creating the client. We're logging in the user, making sure that we have an access token in place. And when the user is logged in, then it means that we can load the to-dos with the access token, and we can also create new to-dos by sending the access token. Okay, loading the to-dos means that we are fetching the /to-dos endpoint that we created, and we pass the authentication header, authorization header. Let's fix this also here, authorization header. And for the to-dos form, for creating new to-dos, we're doing the same. We're getting the data from the form, and we're sending that data in the to-dos endpoint with the authorization header. Okay, so let's try to use this. I think it's already running. I think so. So let's try to run this. And we'll see, first of all, we're getting this, but we're not loading to-dos. And this is probably because we're not console logging in. Yeah, correct. We're not console logging in. So let's wait for this. Let's console log the to-dos. And lastly, let's handle that. Or we can do it the other way around. Okay, cool. So see how now we're loading the page and we're able to see that there are no to-dos for the user, us in this case. But let's now try to create a new to-do. New to-do, gonna set it as completed, submit, and this worked fine. Let's go ahead and check it in Cloudflare. Workers, KB, stream to-dos, like that. And let's try to see if we can find the new to-do that I created. We can. So it's this one because it has the prefix from the user. Good. Now that we have this here, if I reload the page, it should now load the to-dos from us. Yay, it has a to-do. Okay. So we kind of accomplished what we were trying to do, which is properly identifying a user, validating the requests in our backend, making sure that the access tokens are valid, retrieving the user ID from it, and then using that user ID to create retrieve to-dos from the database. Okay, good. End of the stream. Today, we've finally gated the backend application with Auth0. Okay, we did a bunch of steps, but essentially, we got an access token, and we were able to send that access token to the backend API, decode, validate the access token, get the user ID from it, and then use that user ID to identify the user in the database and just retrieve and create to-dos for that user. Very powerful. This is now something that you can do use to build any kind of big application that uses this authentication layer. So that's it. Next stream, a cool suggestion. We're gonna implement Stripe on a Webflow site. Okay, so we're gonna take the Stripe SDKs, dump them in a Webflow site, try to create checkouts, try to purchase stuff. And then if everything goes well, maybe we can come back to this backend implementation and gate things based on a user subscription. So cool things are coming. Thank you for being here. We'll see you on the next one. If you like this, leave a like, comment. Appreciate it. Thank you. See you.